All right, so I am working on the practice test here. Thought this would be, videos here would be maybe a little bit more useful than videos for the unit review. So do these and then go find any problem you struggled with on the practice test. Go find a problem on the review that's like it, tackle that one, and take a look at the key. So number one is really a parent function and transformations problem. So the first thing I'm going to do is start by graphing 3 ln of x minus 1. So I'm going to identify these transformations first. The first thing I'm going to do is talk about what ln looks like. So the parent function for ln goes through the point 1, 0, and then as long as then your next point is 2.71. So your key points here are 1, 0, and 2.71 for your parent function. And that was from the last unit. And our transformations that are happening to those 2 points. The 3 is a vertical stretch by 3. So what's going to happen there is we're going to multiply that 1 is the only one that's going to be affected. That guy there is going to become a 3. And then minus 1 is moved right 1 unit. So we're going to pick up that whole graph and move it right 1 unit. So I think it's easier just to start by graphing and then doing the kind of talk about the domain and range. So I'm going to, usually I have an asymptote on the y-axis. That's going to be moved over 1 unit. My x-intercept is going to be moved over 1 unit. So instead of at 1, 0, it's going to be at 2, 0. And then instead of 2.73 with that vertical stretch, I'm going to do 3.73. So 3.7 and then up 3. Or if you want to count from your asymptote, since you moved your asymptote right 1, everything else you just count, refer to that. That works. And 2 points is good enough. I'm happy with that. So there's my function. My domain is x is greater than 1, because I have that vertical asymptote. So in interval notation, 1 to infinity, not including 1. In set notation, x such that x is greater than 1. Let's go ahead and do range as well. Our ln graph is going to hit all our x's and all our y's here, down to up. So negative infinity to infinity, or y such that y is an element of the real numbers. We already stated the transformations, I just didn't put them in the right spot. So vertical stretch by 3. And right 1 unit. Our vertical asymptote is at x equals 1. Just fill in those details. And now we need to find the inverse. So to find the inverse, I start by just rewriting f of x is equal to 3 ln of x minus 1. So anytime we're finding an inverse, whether it's with a natural log or an exponential or any other function, we change our f of x to y. Switch x and y. And solve for y. The tricky thing about solving for y here is that we need to get rid of that ln. So the first thing, I need to get the ln all by itself. So I'm going to divide both sides by 3. That's not bad at all. X over 3 equals ln of y minus 1. This is where students usually get stuck. And this is where you have to use the fact that this is a logarithm. So it's a logarithm with a base e. And in order to undo the log, we use the exponential. And this is where you do your little leapfrog guy. E to the x over 3 equals y minus 1. So this is how you rewrite that. E to the x over 3 equals y minus 1. And then you can just add your 1 over. And that is your inverse. You can graph the inverse off of transformation. So here, it would be down 1, and it's a 1/3, so that on the inside of the function. So I would actually probably rewrite that like this: 1/3 x minus 1. So the minus 1 is down 1. And the 1/3 on the inside of the function is going to be a horizontal stretch by 3. The other way you can graph this is, if you're sure you graph the original function right, switch your x's and y's, and that'll give you the correct ordered pairs. So e to the x, the parent function, has a horizontal asymptote on the x-axis and goes through the point 0, 1. Your key points here are 0, 1, and 1, 2.7. Approximately 2.7. So I'm going to move that asymptote down 1 unit. I'm sorry. I moved that. See, when you don't show your work, you're probably screaming at the video. That's actually +1, Mrs. Luxick. You're right. Up 1. So that asymptote moves up 1. This is why it's good to show all your steps. There we go. And that inverse really just helped me check my work, because my vertical asymptote is at x equals 1. So my horizontal asymptote should be at y equals 1. Sorry about that little mistake there. Now we're good. Up 1. So our point at 0, 1 is going to be moved up to 0, 2. And then our point out at 1, 2.7, we're doing a horizontal stretch. So instead of 1, that's going to be stretched out to 3. So we're going to go out to 3, 2.7. So 3, 1, 2.7. It's going to be 2.7 from our asymptote. So it's going to be up to 3.7. Again, you can double check it a couple different ways. You're going to have symmetry across the line y equals x, which is really helpful for you. So that's this line right here. Symmetry across the line y equals x. You're also going to be able to flip those ordered pairs. Okay, last piece, domain and range. The domain of our inverse here is all reals. We're going to use every x. For our range, we're moved up 1. So we're not using any y values below 1. So 1 to infinity, or y such that y is greater than 1. And you'll notice that you're just like our ordered pairs switched. We have the ordered pair 2, 0, and the ordered pair 0, 2. We have the ordered pair. This was these guys are switched. Our domain and range are switched as well. The domain of our original function is the same as the range of our inverse. And the same with the range of our original function is the domain of our inverse. That's the nice thing about knowing that relationship about the x's and y's switching. All right, hopefully that was helpful. We'll see number two.